So today's problem is coin change 322, 322. So so the idea is I have a coins, um, in, like, as they said, 1 to 5, 1 to 5 in the array. I have like infinite amount of every type of coin, and then I need to figure out what the minimal fewest number of coins that I can need to make that to make up that amount. So let's say I wanna have amount, and here it's like amount is 11. So amount, so coins, call this array, amount is equal 11. So, and I need to figure out what the fewest number of coins I need to add up to this amount. It's like you are the bank and you have the coins, and your goal is to customer comes to you and asks to change like dollar amount or like whatever like into the coins, and you need to like to figure out how many how actually what the combination of coins will like you can give the money that give back to customers, so it adds up to the amount, and it's the fewest number of coins you want to give them. So the size of the coins, number of coins, is like less than 12. Um, so the idea is, let's say we want to have like amount 11. How we can come to 11? Yeah. So the values of the like amount is 10 to the power of 4. So I can just save this amount in the array. Um, this is the index 11 actually. Index 11. So how I can figure out like what the dp of the I. dp is the fewest number of coins to get amount equals I. So it's gonna be the minimum for the 1 plus dp, and let's say we have coins equal the set ci, where I from 1 to k. So it's going to be minimum dp of I minus actually, let's say cs minus I minus cs, where s from 1 to k. So this is a formula, and to calculate it Um, I'll have this array. Let's say I have this array dp. Um, okay, I have this array 1, 2, and 1, 2, and 5. So dp array of dp gonna be, and I gonna be here. So I gonna be from 1 to 11. Let's say I split it like here, split it like here, split it like here, and then amount 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, 10, and then let's add another one, 11. So, and the dp value of there, so 11 is gonna be, to get 0, I'll have like 0 minimum combinations. To get 1, I need 1. To get 2, I need 2 combinations, because like it's gonna be 1 plus dp of 2 minus 1, or like minimum dp 2 minus 2, and dp and here let's say we put like 9, something like big number. dp 2 minus 2, and then dp 2 minus do we have 5? Yeah, I guess we have 5. dp 2 minus 5, and dp of I, where like I is less than 0, less or equal 0, gonna be like plus infinity. And in case it's like plus infinity, it means it's like uh, not reachable. Yeah, it's reachable for 0, like just 0, but it's a special case. Let's put it like infinity as of now. So this one gonna be minimum dp. This one 1. This is gonna be 0. This is gonna be minus 3. So this one will be dp gonna be infinity, infinity, and then here gonna be 1, and I need 1 plus 1. Here gonna be 3. Here gonna be 2. Here gonna be 5. So the minimum like gonna be 2 and 2, 2, and 1. So it's gonna be 3. For the 6, so how to calculate dp of 6? So the dp of 6 gonna be 1 plus minimum dp of 4, or dp of 5, or dp of 1. So dp of 4 is equal 2. This one is equal 3. This one is equal 1. So the minimum is gonna be 2. And so on and so forth. I can go up to the 7, and yep, that's basically the idea for this solution. So I can start solving this problem by like iterating the dp array one by one sequentially, and like resolving the minimum number of combinations I need to get. So if I'm gonna put 0 here. Yeah, like 0 here should be 0. Maybe just 1 plus 0. Yeah, that's it. So I'll have the dp equals new int amount plus 1 for int I equals uh, plus 1 I less than amount I plus plus. Then I'll do um, int minimum equals dp. Let's say integer. Let's say my integer max value, and then for int. So for every amount, I will iterate the coins, and the coins array is maximum 12. So the complexity gonna be 10 to the power of 4 multiplied by 10 to, so 10 to the power of 5. If this is less than 0, then you're gonna have integer max value. Otherwise, I'll have this 1 plus dp, and then I'll take the minimum between z1 value and the minimum, and then dp of I equal minimum, and the return dp of amount. And then I need to check if it's like impossible to get the amount. I'll go check amount is equal -1. Integer max value, then -1, otherwise dp of amount. So let me think about that. If I gonna start with a 1 to 5 array, let me paper trace it. So I'll have like 1 to 5 like coins equal 1 to 5, and then amount is equal 11. So I'll have this dp array. It starts from 0 element. So here 0 is 0. To get 1, I need to add 1. So to get 1, I have an integer max value as a minimum. Then I go through the coins array and I'll subtract it. subtract current I minus coins j. If it's less than 0, then it's going to be integer max value. If it's greater or equal 0, it's going to be 1 plus dpi. So I here, let's say I equals 1 initially. So I'll add at the index 1 I1, so I'll add I plus dp of 1 minus the first coin 1. So 1 plus 0, and it's gonna be all the next coin gonna be 1 plus dp 1 minus 2, and then 1 plus dp I 1 minus 5, and they're like both gonna be negative. dp 1 minus 5 gonna be 1 minus 5 gonna be negative, so this one not gonna be selected, max value gonna be selected. So the only minimum that's available here is like this one. Something like this. If dp of I equals integer max value, okay. So there might be a problem with like if dp is not filled. So initially, if I go through the dp array, so here I need to check if dp is not 0. So if dp of I minus coins j, so if it's like greater or equal 0, and dp dp I minus coins j not equal 0, if it's greater or 0, or if it's equal 0, or like this. Um, so dp of I still. So I wanna check the array dp of 4 and I equals 0. Let's paper trace it. Better paper trace it. So initially I have so I have coins, just 2, amount 3. So I is equal 1, integer max value, min equal of max. So for j equals 0, j less than coins length j plus plus, if I minus coins j equals 0, so I is equal 1, coins j is equal to, so it's gonna be minimum. I'll store the minimal as integer max value. So the dp of is gonna be 0 and then max value. Then I equals 2, then minimum equals max. Now again go through the j coins. I minus, so 2 minus 2 equals 0. So I should store dp gonna be 0 max 0 now. So like the next one is I equals 3. So the minimum equals max. Again, I go through the what's going to be I minus coin. So through the 3 minus 2 gonna be equals 1. Ah, okay. So it's overflow here. So if I add the maximum and dp I minus coins j not equal integer max value. Okay. Can I do better here? Sort? Okay, yeah, so I can multiply all the coins. And if it's not multiple, I can just break. Huh, this is a pretty long one. So it's basically what it does. So let's check what I was submitting before. Here, not that good. A little bit better. Mm. So I really like this idea, all multiply. Uh, I probably can improve it here. Or like I can write it by myself. So let's say I want to have 4 int I equals 0. Oh, let's say for int j equals 0, j less than coins length j plus plus. And then if the amount boolean all multiply equals false, equals true, equals at least one multiply, let's say. At least one multiply equals false if amount over coins length coins j is equal 0, then at least one multiply is equal true. If not, at least one multiply return -1. Mm. So it shouldn't be like that multiple. What that? No, that's not true actually. Because it's like polynomial. So we have coins like coin 0 multiplied by amount 0 plus coinus 1 multiplied by amount 1 plus coins 2 multiplied by amount 2, so on and so forth. And then plus equal amount. And this one can be
Can be zero or can be positive. And when I check the division, I check that only against like one of them, but it might be a combination of couple of them. Um, can I check all combinations? So the all combinations gonna be, so I'll have one. If I sort, so still, yeah, even if like I say that I have like specified C amount 0, amount 1, and so on, how I can check it against, or like if I know that amount 0 and amount 1 greater than 0, then I cannot check it fast. Let's check again. So they say they have this weird algorithm. Let's add this one to the. I just want to check how this part improves the solution. Yeah, it doesn't improve significantly. So it must be this algorithm. Yeah, it must be something in this algorithm that works really efficiently. If I gonna remove this one, to simplify it. Huh, interesting. Is it used somewhere else? So this one is important part on multiply. Yeah, this one is important part. Okay, okay. So I'll probably add that to the gist. Let's add this. Okay. Okay, so I'm gonna wrap up. As I said, oh, I didn't say that. Made a few mistakes for this algorithm, so it's gonna be again fail. But you see that like almost 3 years ago, I was solving it with pretty kind of verbose code, and now it's much more kind of efficient, I would say, um, like this. Yeah, that's it.